Okay, so let's talk about phase diagrams. This is standard 2.1.3, and we're going to talk about how to read this graph because it's essentially just a graph. There are two things that a phase of matter depends on, and that is the pressure and the temperature. We know from heating and cooling curves that as you increase temperature, you're increasing the energy in a substance. Therefore, you are changing the phase of matter because gases have more energy than liquids, and liquids have more energy than solids. However, if you apply enough pressure, you can actually make matter stay in a certain phase. Now, there are three phases represented on this graph. You've got the solid phase, which is everything left of that black line. You have the liquid phase, which is square in the middle, and you have the gas phase, which is everything to the right of the black line. All of those vocabulary words on this phase diagram simply show what the transition between two phases are. So if you're going from solid to liquid, you're melting. If you're going from liquid to solid, you're freezing. If you're going from liquid to gas, you're vaporizing or evaporating. If you're going from a gas to a liquid, you're condensing. Going straight from a solid to a gas without passing through the liquid phase is called sublimation. Dry ice does this, which is liquid or solid carbon dioxide. Solid carbon dioxide, when exposed to normal temperatures, goes straight to a gas, which is why it is used in smoke machines and generally Halloween. Gas straight to a solid is deposition. So let's do some practice problems with a blank phase diagram. So you're going to get a blank phase diagram on your midterm. You got one on your test on this unit, and you will probably see this on the final as well. Okay? So X is a solid because it is in the solid portion of this diagram. Y is a liquid. X can be found at somewhere roughly around 58 kilopascals of pressure and about, we'll go with negative 125 degrees Celsius. Y is roughly, so these are X, Y is roughly 105 kilopascals, and X would be, and the temperature would be about 25 degrees Celsius. Again, because the graph is not denoted more specifically, it's just a rough estimate. But you will be able to get the correct answer on the test. Now, let's say, for instance, that the question asks you what phase change happens when you move from X to Y. Well, X is a solid and Y is a liquid, and when we move from a solid to a liquid, we are melting. What about the reverse? If I'm moving from Y to X, that's a liquid into a solid, that would be freezing. What if the question asks you what happens to Y if I decrease the pressure? Well, I'm starting at this pressure, and pressure increases in this direction, so decreasing would be this point moving downwards. That's the decreasing pressure. So I started out at a pressure of 110. Let's take it down all the way to a pressure of 10. Okay? Notice I'm not changing the temperature. Same temperature going from a higher pressure to a lower pressure. That's going from a liquid to a gas, which would be evaporating or vaporizing. Okay? Now, let's do another situation. What if I raise the temperature of X from roughly negative 125 degrees Celsius all the way to 100 degrees Celsius? What if the question asks that? You take X, without changing the pressure, you're going to increase the temperature all the way to 100 degrees Celsius. That means that it goes from a solid through the liquid phase to the gas phase. It's important that you're able to understand what changing pressure and temperature has, what effect that has on the state of matter, and that you're able to read the graph and take each point through the transition phases. The other thing you need to know is that this is the critical point. Up at the top of the line that separates liquid and gas, this is where a liquid and a gas become indistinguishable from one another. This is the triple point. This is where all three phases of matter can exist at the same time. So we'll go with negative 75 and 30 kilopascals. All three phases of matter can exist at the same time because that is at the triple point. All of these vocabulary words are on this diagram. You simply need to know how to transition from phase to phase and how to increase pressure, decrease pressure, increase temperature, and decrease temperature.